everyone. So I know you all said that generally you like the digital videos, but I'm going to try a little paper-based video today and see how it goes. All right, so let me just go ahead. I'm going to mark here where okay, let's see how this goes. All right, so today you looked at inequalities, and these are inequalities in one variable, meaning that each one of them only has one variable in it. So this is select all the values that are a solution to the inequality. So the best way for us to figure this out is to plug in these for x and see which ones work. That's one way to do it. Sorry, I said best way, but that's the one way to do it. Another way that we can do this is that we can go ahead and try to solve this and see what answer solutions might work. So let's do that. We have 7x plus 6 over 2 is less than or equal to 3x plus 2. Now I have this 2 in the denominator, and remember we don't like that 2 in the denominator, and one way that we can get rid of that is that we can multiply the whole thing by 2. When we do this, 2 is now being multiplied times the numerator, and so 2 over 2 cancels out. However, we do need to multiply 2 times the rest of the inequality. So we're left with 7x plus 6 is less than or equal. 2 times 3x is 6x. And then 2 times 2 is 4. All right, now I can go ahead and subtract 6x from both sides. And when I do that, I get 4 on this side. We're going to bring down our sign. 7x minus 6x is x plus, bring down our 6. All right, now I can subtract 6 from both sides, and I will get x is less than or equal to negative 2. This means that any number that is less than negative 2 is a number that will work in our inequality. So that means that negative 3 works and negative 2 works. Negative 1 is greater than negative 2, so that does not work. 0 is greater, 1 is greater, 2 and 3 are all greater. And if you wanted to see, we can check. Let's plug in 0, because again, that's an easy one. So 7 times 0 is 0. 6 divided by 2 is 3. Is less than or equal to 0 times 3 is 0, 2. So 3 is not less than or equal to 2, and so therefore we know that 0 does not work. So if you wanted to check each one by plugging it in, you could do that. That is one way to do it, but it might actually, since there's quite a few answer options here, be faster for you to solve the inequality, find out what values would work, and then select the ones that will. All right, let's look at this one right here. So this is find the solution set to this inequality. 2x minus 3 is greater than 2x minus 5 over 2. So again, we have 2x minus 3 is greater than 2x minus 5 all over 2. And I want to, again, eliminate this 2 in the denominator. So I'm going to multiply the whole thing by 2. 2 divided by 2 gives me 1, so this is canceled out here. And then this still needs to be multiplied here. So we're left with 2 times 2x is 4x. 2 times negative 3 is negative 6 is greater than, and this is what's left here, 2x minus 5. Now I can go ahead and you can really move the x to either side. I'm going to move the x this way and subtract 2x from this side to lump our x's together, because then I will still have a positive number on this side. So 2x minus 2x is 0. 4x minus 2x is 2x. Bring down minus 6 is greater than negative 5. Now I'm going to add 6 to both sides, and we will get, and bring down 2x. Let's see that. 2x, this cancels out, is greater than negative 5 plus 6 is positive 1. Divide both sides by 2. We get x is greater than 1/2. So our answer is going to be B. Okay. Now, C and D you could automatically eliminate because they have less than or equal to and greater than or equal. We can't suddenly go from just a greater than sign to including the equal signs there. So that can help you to eliminate that. All right, let's look at the next one. So it says, here is an inequality. What value of x will produce equality or make the two sides equal? So if we were to do negative 10 plus x all over 4 plus 5 is greater than or equal to 7x minus 5 over 3. All right, if we wanted to figure out when these are equal, we're going to solve this like any equation. The only difference here is that we have denominators that are not super awesome to work with. Now, you could multiply by 4 to get rid of the denominator here, or you could multiply by 3 to get rid of the denominator here, or we can multiply the whole thing by 12. Because if we do that, 12 divided by 4 is 3. So we're left with just a 3 to multiply through here. And so that would be negative 30 plus 3x. And then we still have to multiply the 12 by this 5 here because the 5 is not over the 4. So 12 times 5 is 60, so plus 60 equals, again, we have to multiply the whole thing through. Now here, 12 over 3 is 4. So we're left with 4 times 7x minus 5. So 4 times 7 is 28x. And 4 times negative 5 is negative 20. Now I want to combine like terms. So I need to get my x values together and my constants together. So I'm going to subtract 3x from both sides because the x value is larger over here. And so this will cancel out, and I'll get 25x minus 20 equals negative 30, and positive 60 is going to be 30. And if I add 20 to both sides, I'll get 25x equals 50. Therefore, if I divide by 25, x equals 2. All right, so that means if I were to plug that in here, these two sides should now be equal. So 2 plus negative 10 is negative 8 over 4 plus 5 is greater than, or sorry, we're saying when it's equal. So equal to, plugging in 2, 7 times 2 is 14 minus 5 is 9 over 3. So this gives me negative 2 plus 5 equals 3. That is true. That works out. So x equals 2 is when those two sides are equal. All right. This gives you some practice with fraction work and multiplying fractions. So just thinking through what happens when we do that. All right, Noah is solving the inequality 7x plus 5 is greater than 2x plus 35. First, he solves the equation 7x plus 5 equals 2x plus 35 and gets, gets x equals 6. How does the solution to the equation help Noah solve the inequality 7x plus 5 is greater than 2x plus 35? So the way that this helps us solve it is it gives us our boundary. So if we say that 6 is the number we're looking at as our boundary, when those two sides are equal, we now want to see when it will be less than and when it will be greater than. And so here we're looking at a greater than sign, so this is going to be open. And now what I can do is I can test on either side of 6. So a number to the left of 6 that's easy to substitute is 0. So let's test 0 somewhere down here, right? 1, 2, 3, 4, 5. We'll say 0's here. So 0 times 7 is 0 plus 5 equals 0 plus 35. And we're looking at when it's greater than, right? So 5 is not greater than 35. That means 0 doesn't work. So that means things to the left here do not work. Well, let's try. We have 7, 8, 9, 10. Let's try 10. 10's a nice even number to try. 10 times 7 is 70 plus 5 is 75. Is that greater than 2 times 10 is 20 plus 35 is 55? Yes. So the number on this side works, which means that our arrow will be pointing this way. And so we would say x is greater than 6. Okay. All right. Number 5. Which graph represents the solution to 5 plus 8x is less than 3 open parentheses 2x plus 4 close parentheses? All right, so first of all, we want to figure out, we see that this is less than, and we have all open circles. So it could be any one of those graphs initially looking at that. The next thing I would want to do is to go ahead and solve for what my boundary would be. So let's look at that. 5 plus 8x is less than, I'm going to go ahead and distribute this, 6x plus 12. Now let's go ahead and subtract 6x from both sides. We'll get 5 plus 2x is less than 12. I'm going to subtract 5 from both sides, and we will get 2x is less than 7. Therefore, x is less than 3.5. All right. Now, we see that we have lots of middle grounds here. So that helps us out. And we know that we're looking at less than 3.5. So we know that it cannot be A because this is going to the greater than side. And we know it cannot be C because this is also going to the greater than side. So it either has to be B or D. Let's look at which one would probably be the best. So I would say it depends on how honestly you labeled your graph, but let's assume that 0 is somewhere in the middle here, and so that this would be, if 0 were here, this would be 1, 2, 3.5. This would be negative 3.5, so negative 3, negative 2, negative 1, 0, versus this would be the positive side of things. And since it's positive 3.5, I'm going to go with D as my best answer. Okay, because this isn't labeled, you could potentially argue B, but we're going to assume that this would be more on the negative side of the graph and this would be the positive side of the graph. All right, let's take a look at our next piece here. All right, so it says solve the system of linear equations without graphing. So we are getting now into some review of previous lessons. So here we have these two have the same coefficient, but they do not have opposite signs. So that means I'm going to subtract. And remember, when I subtract, I'm subtracting the entire thing. So 7x minus 7x is 0. That cancels out nicely. 11y minus 3y is 8y. And negative 2 minus 30 is negative 2 minus 30 is negative 32. All right, so now I can go ahead and divide by 8, and I get y equals negative 4. I now have one answer, and so I can plug that back in for x. 7x plus 11 times negative 4 equals negative 2. 7x, 11 times negative 4 is negative 44 equals negative 2, and you should now be able to solve that. So I'm going to stop here, and you can continue and tell me what you get for x. All right, number 7. We have our friend Kieran. He has 27 nickels and quarters in his pockets worth a total of $2.75. Write a system of equations to represent the relationship between the number of nickels, the number of quarters, and the dollar amount in this situation. So we have 27 nickels and quarters. So N plus Q equals 27. Some number of nickels plus some number of quarters gives me 27. We know that a nickel is 5 cents, so that's 0.05 N plus 0.25, because a quarter is 25 cents, Q equals $2.75. So now we've created a system of equations. It says, how many nickels and quarters are in Kieran's pocket? Show your reasoning. So again, we can approach this from a couple of different avenues. I can go ahead and eliminate by multiplying something, or I can go ahead and substitute by solving for N or Q. Either one would be okay. My personal preference is elimination, so that's what I'm going to do. So I'm first going to line these up, and I'm actually just going to rewrite this a little bit so it's easier to look at. N plus Q equals 27. And then I'm going to say, well, honestly, the thing that I want to get rid of are some of these decimals. So I'm going to go ahead and multiply the bottom by, if I want to make this one equal to this, I would multiply it by 4, but I need to multiply by -4 because I need to go ahead and create opposite signs here. So if I rewrite this equation now, it's going to be 4 times 0.05 is going to give me, and this is a negative too, so negative 0.2 n. And then a negative times a positive is going to be negative, and that's going to be negative 4 times 25 cents, right? Or 4 times 0.25 is going to be 1. So negative Q, negative 1Q, equals 275 times -4. So you can go ahead and you can either multiply that out or go ahead and feel free to use your calculator. But let's see. 275 times -4 is going to be -11. Okay, so now we have a new equation from this one, and I can now combine N plus Q equals 27. So let's go ahead and combine that. 27 minus 11 is going to be 16 equals Q minus Q is 0. And then N minus 0.2N is going to be 0.8N, right? Because this is 1N minus 0.2. So now I'm going to divide by 0.8 on both sides, 0.8 on both sides. You'll get 16 divided by 0.8 is going to give us N equals 20. This means I have 20 nickels. And then I need to figure out how many quarters. Well, if I have 20 nickels then and 27 coins total, then that means that I have 7 quarters. Okay? And when it says show your reasoning, as long as you've demonstrated how you manipulated your system of equations, that is sufficient. All right, let's look at number 8. How many solutions does this system of equations have? Explain how you know. All right, so to figure that out, I'm going to put everything in y equals mx plus b form. So this is y equals, I have to subtract -2/3 x from both sides. So y equals -2/3 x plus 4. That's the first equation. The second equation, if I'm solving for y, I'm going to go ahead and subtract 12 on both sides. And so we'll get 2x minus 12 equals -3y. Divide both sides by -3. We're going to get y equals, this cancels out, so -2/3 x. And then -12 divided by -3 is a +4. And so if you look, these two equations are actually exactly the same. And so this tells us that we will actually, in fact, have infinite answers, because if they have the same slope and the same y-intercept, they are actually the same line. So they're both negative, they're both starting at 4, they would both be this same exact line. And so all their answers are overlapping, which means they have infinite answers in common. Okay, number 9. The principal of a school is hosting a small luncheon for her staff. She plans to prepare 2 sandwiches per person. Some staff members offer to bring salads and beverages. The principal has a budget of $225 and expects at least 16 people to attend. That's a very small budget, y'all. Sandwiches cost $3 each. She must be making them by hand. All right, so select all of the equations and inequalities that could represent the constraints in the situation where n is number of people attending and s is number of sandwiches. So n is number of people. it says n is greater than or equal to 16. Well, she did say she expects at least 16 people to attend, so 16 or more people. So A is a very good constraint to have. B, n is greater than or equal to 32. That's number of people. We're not expecting more than 32 people necessarily. There could be, but it's at least 16. So B is not an answer option. S is less than 2n. So that's sandwiches, the number of sandwiches is less than 2 times the number of people. She said she plans to prepare 2 sandwiches for each person. So that would at least need to be, there would need to be an equal sign, and it would need to be not less than 2n, right? The number of sandwiches is going to be 2 times the number of people. So this is not accurate. However, D is accurate because the number of sandwich would equal 2 times the number of people. So if we had 16 people, the number of sandwiches would be 32. If we had 18 people, the number of sandwiches would be 36. Okay, so this one would be an equality. Letter E says 3n is less than or equal to 225. So this is $3 each times the number of people has to be less than or equal to 225. Well, she's making more than 1 sandwich per person, right? So 3 times the number of people will give us 1 sandwich per person. Has to be less than or equal to 225. That's not true. Instead, we're looking at 3 times the number of sandwiches has to be less than or equal to 225. So that is, in fact, true. All right, our last one is students at college are allowed to work on campus no more than 20 hours per week. So their hours have to be less than or equal to 20. The jobs that are available pay different rates, starting from $8.75 an hour. Students can earn a maximum of $320 per week. So that means that their earnings have to be less than or equal to $320. Right? At least 2 inequalities that could represent the constraints in the situation. Be sure to specify what your variables represent. Okay, so I already wrote them, right? H is less than or equal to 20. The number of hours have to be less than or equal to 20. Could they work 18 hours? Yes. Could they work 25 hours? No. We can also say that the number of hours they work times whatever rate they are making, so however much they are making, has to be less than or equal to $320 because that's the maximum that they can make. All right. And then it starts from $7.85 an hour. So the rate has to be greater than or equal to $8.75. Could they make less than $8.75? No. Could they make more? Sure, maybe depending on the job. So these are just some examples of the inequalities that you could write for this situation. All right, that's it for your homework. I hope you, well, let me know what you think. Okay, our code word for today is shamrock. Shamrock is your code word because my son left this milk container from Shamrock Farms sitting on my desk. All right, happy homeworking. See you tomorrow. Bye.